All right. So hopefully we have a few more people joining us here in the next couple of minutes. I'll start out with some clarifications, some housekeeping stuff. So let's see here. So I'm kind of forgetting some of the settings here between Top Hat and Canvas. So I've got it now. So if you want to go back and review Module 1, it kind of had an end date just because I forgot to kind of have it just so it's open-ended. I have to go back and change it so it's set for review. So it wasn't worth any points. It's showing up that it's worth points here. It's kind of why I emphasized there's no points. And it should be able, if you go to Top Hat, you can go back and review this module now. Every other module that's assigned for points, like Module 2, so that was due before we started class today, those will be set for review once that due date passes. So you should be able to review that now. We'll kind of pick up where we left off in the inflation Module 2 slides. We'll finish those up today. We'll have a daily quiz that we kind of cover through during the lecture. I have a set of practice problems up for that first quiz, which will go over modules 1 and 2. That quiz is due before the end, at the end of the day on Friday. So you can start to review those practice problems. We've completed all the material today that you would need to kind of get on and complete that quiz. I have it set to be open today at 3:30, so a little bit after class ends. I would suggest reviewing those practice problems, reviewing some of the in-class questions that we use in those daily quizzes. Excuse me. Before you sit down and take that quiz. Okay. So when I say reviewing those, you'll kind of have those questions that we've covered. The due date hasn't passed. So you won't be able to kind of go back and look at them once you submit it because some people haven't watched the recording yet. So really these practice problems are going to be some good ones to go through before you sit down and take that quiz. They'll be pretty representative of what you see on that quiz. Reviewing the top hat questions would also be a good thing to do prior to sitting down to take that quiz. So it's only going to cover modules 1 and 2. So unemployment and inflation. I also have the module 3 materials starting to kind of already get posted up there. So I've got the PowerPoint slides. I've also got that module 3 reading, which is due before we start it tomorrow. So once again, kind of going through that prior to the lecture. From here on out, every module reading will be due before we cover it in class. To kind of give you a little bit more, I don't want you to work too far ahead, which is why I kind of have these set to release, not weeks in advance. After today's class, I'll also kind of get that module 4. Oh, there it is. Top hat. So if you want to kind of work ahead a little bit, we won't start covering module 4 until next Monday. But if you want to get an early start on that, I'll have that set to be released after we get done with class today. Okay. I also am aware there's some bugs in module 3. I think they should all be fixed now. It was being case sensitive, even though it was selected to be case insensitive. So I've added in some things, so that make sure that if you have a comma or you miss a dollar sign, it'll still count it as correct. So if you go back, those grades should be adjusted if you did that. I might go back and look at the responses. If it caused any issues, I'll make sure I fix those manually, but that should kind of be scoring them correct now. If you have some concerns, mostly it was like questions 1 through 4. They should be set correct now. Okay. Other than that, any questions for me before we kind of jump into material here today? Move it over a little bit so I can see if there's anything in the chat. Okay. All right. So we left off talking about inflation. So I just kind of had pulled this. Also, I updated the slides a little bit from what they were posted. So I updated those this morning. Working on with me, I changed some things around a little bit. I can add this in where you can see the same goods, right, from McDonald's are more expensive in 2006 relative to 1995. So this is the idea that when prices are going up, we have inflation. So we talked about inflation last class. We talked about the costs of it. We talked about how do we determine purchasing power? Well, if you have the same income, say $50,000, but prices go up, yeah, module 1 isn't worth any points. Right. So there was no points associated with it. It's simply set for review. Okay. Because I didn't have it, couldn't assign it before we covered it in class the first day. Okay. So you should be able to just go back and review the answers. There's no right or wrong because it was worth 0 points. Okay. So we said, We can think of purchasing power as if I have the same income, but prices go up, I can buy fewer goods with that same amount of income. Okay. So we also went through some examples where what if my income goes up, but prices go up by even more, right? So we did all of this last class to determine purchasing power, and we'll use this idea of purchasing power in some of the topics that we covered today. Okay. So how do we actually measure inflation? So before we get there, we're going to need to talk about something called the Consumer Price Index. Okay. So what the price index does is it looks at a typical market basket that is purchased by consumers. So we have this broken down into certain categories. I'll use some toy examples where we have 2 or 3 goods. In practice, for an entire economy, we would look at every single type of good an individual is buying, right? That would be our market basket. The price index, we would then look at, okay, of these goods that people are buying, what's the average price, of those goods? So to determine the cost of this market basket, we would take the quantity of each good that they're purchasing, multiply that by the price. That gives us the average price of the goods in that basket. We're then going to use that to calculate this price index. So when we're doing this, for an entire economy, we aren't just going to have 2 or 3 goods. We're going to have thousands, right? So generally, when you look at these numbers that are calculated by government agencies, they look at a handful of goods in each one of these categories. They kind of break this down. They look at the average number purchased in each category times those prices, add them all up. That gives them the cost of what we call the market basket. Okay. Oh, there we go. So how do I calculate this price index? Okay. So what we want to do, right, is determine what the cost of everything that someone is buying today to the cost of everything that someone is buying tomorrow. Right? If costs have went up, we've got inflation. Okay. So the way that we're going to measure this, right, is through something called a price index. So the price index is going to be what was the cost of today's market basket, the goods that people are buying, relative to the cost of that same market basket, the same quantity of those goods, but at the prices in what we call our base year. So a lot of the times it's comparing, say, 2010 to 2009. We'll use some examples here today where maybe we want to compare to a decade prior. So maybe 2010 to 2000. Once we have that ratio of the costs of these market baskets, we multiply it by 100 to get our price index. So what would the price index always be of the base year? Well, if we're calculating the price index of the base year, then today's market basket is the base year. Anything divided by itself is 1. We get a price index, and that base year is always going to be 100. So if you see a price index of 100, that is your base year. Excuse me. So we'll kind of work through an example. How do we calculate these price indexes? So I've got some numbers here. I'll kind of explain where they come from. We'll do one later on where I kind of work through the math a little bit more in detail. But here I've got what this market basket quantity is. Individuals in both these time periods purchasing 100 gallons of gasoline and 2 laptops. Right? We then have the corresponding prices in 2010 and the corresponding prices in 2011. So to determine the cost of this market basket, we need to determine the cost of the units that someone is buying in that year. So to get the cost of gasoline, we would take in 2010, they're purchasing 1,000 gallons, multiply that by the price. This is the cost of gasoline. The cost of the laptops that the average consumer is buying, they purchase 2, price is $850. Here's this amount of money they're spending on this second good laptops. Now, once again, in the entire economy, we have much more than 2 goods. Here we're going to simplify. Once I have the cost of each good, to get the total cost of my market basket, I would add up how much they're spending in each one of those categories on each good here. So add these up, I get in 2010 to buy this amount of gasoline laptops, it was costing consumers $4,500. In 2011, I used those same quantities, but using the new prices from 2011. So 1,000 times 3.8, 3,800, 2 times 400, 800, add them up, gives me the cost of that same market basket in 2011 is 4,600. So to determine what my, price index is, well, in 2010, the cost of my market basket divided by the cost of my market basket in the base year. So here we're going to assume the older time period is my base year. If that's my base year, 4,500 over 4,500 would give me that price index of 100. That's always going to be the price index of our base year. If our base year is 2010, In 2011, we'll take the cost of that market basket, divide it by the cost of the market basket in my base year, and then multiply it by 100. So essentially, this is like the ratio of the prices in those two time periods. If that numerator is higher, that tells me that prices have increased on average, or I've got inflation. If that numerator is smaller than the base year, that tells me on average prices have went down, right? Or the goods that individuals are buying, the prices on average decreased. I then multiply it by 100, similar to when we were calculating things like inflation. We want things in terms of a percentage. Here, that price index, that's just how we calculate it to kind of give us these nice larger values to look at. So one thing to kind of emphasize is this price index is using the same quantities to calculate the cost of the market basket in each year. So it's essentially controlling for the amount of goods that people buy and just looking at the differences in prices. Okay? So these price indexes are a good identification of inflation or deflation. Same quantity in both years, but using the prices that are different in those time periods, that's how we calculate the price index. Okay. Now, what if I'm looking at 2020 compared to 2000 and I'm using 2000 as my base year? So here, I can kind of compare two time periods. I could also do the price index for 2010. So I'm going to actually do all of this in Excel. You could do this by hand. But I think, showing you how we use software and tools can make our life a little bit easier. Oops. Didn't like that. Hold on. So I'm going to copy this. Why doesn't it like this? Well, try doing it manually. There we go. So make it so we can see all this. Make this one a little bit smaller. All right. And then we'll go to view. I'm going to make this a little bit larger so we can see things. No, that was a little bit too large. There we go. So here I've got 3 different time periods. And the first thing we're going to do is calculate the cost of the market basket in each one of these years. So to find the cost of my market basket, I'll take the quantity of that good that I'm buying, multiply that by the average price of that good, add to it the next good's quantity times its price, add to that the quantity we're buying of the next good times its price. So taking the quantities, multiplying it by the price in that year, that's what's going to give us the cost of our market basket. Okay. I could do the same thing for the next 3 years. Now, the nice thing about Excel is I want to use the same quantities, but I want my cell references to update, so I'm using the new prices from each of the subsequent years. So to freeze those cell references, where I have the quantities, we use these dollar signs. So I'm not sure how familiar everyone is with Excel, but this is something you should hopefully know by now or should be learning along your way in the Kelley School of Business. So we're going to hold kind of the constant those quantities. Now when I copy this across, notice the cost of my market basket in 2020 using those same quantities of the goods, but my new prices. Okay. So if we just look at the cost of the market basket, people are spending on average more. This is a good indicator that we've got inflation. Prices are increasing. How would we calculate the price index or the consumer price index in each one of these years? Well, we said we would take the cost of the market basket in that base year of 2000, divide it by, we would take the cost of the market basket in 2000, divide it by the cost of the market basket in that base year of 2000. So anything divided by itself is 1. We would then multiply this by 100. That gives us our price index for the year 2000. If it's our base year, we should always get a price index of 100. Okay. We could then do the same thing for 2010. So I could freeze some cell references to do this, but I'm just going to kind of go through this step by step to show you, if you were doing this by hand and not in Excel, how you would do this. So in 2010, I would take the cost of my market basket in that year, divide it by the cost of my market basket in the base year of 2000. So I would have to tell you what the base year is. Okay. I'm then going to multiply that by 100. And I get, this is my price index for 2010. I then say, okay, what's the price index for 2020? I take the cost of my market basket, divide it by the base year, and I can see that prices are increasing there as well. Now, this was doing the price index for the base year of 2000. What if instead I want to do the price index, but I told you that the price index for the base year was 2010? Well, it's going to be the same calculation, but instead of dividing by the cost of the market basket in 2000, I'm dividing by the cost of the market basket in 2010. So before I do this, we should know that if the base year is 2010, when I calculate this price index for 2010, it should be 100. In which case, I know if prices are increasing, that when I calculate my new price index for 2000, it should now be less than 100. So I can go through and do this, right? I take the cost of my market basket in the current year, divide that by my base year, which is now 2010. We said we then multiply that by 100. Sure enough, my price index now for 2000 using the base year of 2010 is lower than 100. And then if I take the cost of my market basket in 2010, divided by the cost of the market basket in my base year, which is 2010, I should always get that the price index in my base year is 100. And then I know that if prices are going up, if I'm calculating using a different base year, in 2020, I should now see a price index that's greater than 100 because I take the current cost of the market basket, divided by the cost of the market basket in the base year, and multiply by 100. Okay, so this is how you would calculate the price index for various years using different years as your base year. Okay, so I think the next kind of slide I say, all right, well, what if we wanted to calculate the inflation rate? So if we're calculating inflation rates, right, we're always going to look at changes from the prior year to the current year. So we calculate the price index using a base year, but inflation rates we calculate year to year. Okay, so here price index 1 is going to be whatever the time period was prior to the current time period. Price index 2 is whatever the current price index is. Right? So if it helps, you could think about, here's my current year, here's my previous year, and we always divide by where we started, that previous year. Okay, so if I work through the same example, but I want to calculate inflation rates from 2000 to 2010, and then 2010 to 2020, and then say, okay, is this economy experiencing disinflation? So that's something we talked about last class. But we can do this work in Excel as well. Right? So I'm going to calculate inflation here. Now, in my first year, I can't calculate inflation, right? Because there's no time period prior to it. So, I could think about technically, I can't calculate my inflation for that very first year. But in 2010, if I want to calculate inflation, I take the current year's price index, I subtract the previous year's price index, and I divide by that previous year's price index. So if I hit enter here, I should get my inflation rate as a decimal. If I want it as a percent, I would then multiply that by 100. So inflation here was 52%. Once again, these are toy numbers. 52% would be an outrageous amount of inflation, but that's what it would be given these numbers. Okay. Now, if I copy this over, right, all my cell references will update so that I'm looking at what the current price index is minus the previous year's price index divided by the previous year's time index, multiplying it by 100. So what I can see here is inflation has went up, right? I, in fact, don't have disinflation here. I have inflation in both time periods. My inflation is greater than 0, but it's not decreasing. In order for me to have disinflation, the inflation I would have calculated would have had to be something like 45, right? That would be an example of disinflation, right? I still have a positive amount, I still have inflation, but it's a lower amount of inflation in that current time, in that 2020. Okay. Now, just to point something out here, it doesn't matter what our base year is. So let's say I wanted to calculate inflation using my price index where I had a different base year. So I would still look at the current year minus my old year. I would then divide that by the old time period. And then we said we always multiply it by 100 to kind of get it in percentage form. Sure enough, I get the exact same value. Okay, so it doesn't matter what our base year is, we're always going to find, if we go year to year, the same inflation rate. Okay. I'm going to save this real quick. No, I'll save it and drag it over later. So just so I'll post this after class. So if you were working along with me, you could have this, but I'll make sure I kind of get this posted so you have that available to you on Canvas as well. Okay. So any questions there before we keep moving? Okay. So that's how we would use price indexes to calculate inflation, identify disinflation, or just calculate the price index in general. So what are some issues with this price index? So we'll kind of go through this relatively quickly. We'll talk about different measures of different price indexes, and then we'll kind of use that idea to kind of get to the next topic. Sorry, I need a little bit of water there. So what's the issue with that price index or the consumer price index? Well, even if I buy the same amount of goods and prices go up, that's not necessarily a bad thing because the utility of goods could change. I'll do the flip side, right? So let's assume that I was buying music, CDs in 2000. Well, if I bought the same amount, even though prices might have been, let's say, higher, right? The price index would be relatively high. Well, if the price goes down, people keep buying the same amount in 2025. It's not necessarily that, the prices have necessarily decreased because the same quantity would produce different amounts of utility. So imagine if I'm buying a physical CD in 2000, if I buy 10 of them, that provides me a much higher level of utility than if I bought those same physical CDs in 2025, because I have to go out and find a CD player. I could have just bought them on Spotify, which is a much lower cost, and so, much lower cost to me. It's much easier to access, and so utility changes over time as well. So our price index doesn't pick that up. It can control for quantity, but it doesn't control for the utility of that quantity. Okay? So that's going to be one of the issues that we have with this price index. So this consumer price index is kind of what we were just calculating. It's the average prices of goods that are purchased by the typical consumer. So the average quantity bought by the typical consumer times the average prices of those goods and services. Now, when the government makes these calculations, it tends to weight certain items a little bit more. Everyone needs a house, so it tends to weight that at a higher amount than, say, laptops. Personal consumption expenditure, it's really measuring the same thing, but it has different weights than the consumer price index, and it also allows for that market basket to change year to year. Right? So it factors in that people are going to buy more physical CDs in 2000 than they are in 2026. Okay, so we won't dive too deep into how these calculations are made, but just kind of mentioning here, we do have different measures of price indexes. To calculate inflation, it would be the same equation, we're just using a different price index. Okay. The other two types we have will be a GDP deflator, which we will talk a little bit more about in Module 3. Now, what this does is when we're talking about gross domestic product, it's only the goods and services that are bought, right? Domestic goods that are bought, right? So, for example, if Liberia doesn't produce cell phones, well, they're still purchasing cell phones, but they're purchasing them from other countries. That doesn't really influence the GDP of Liberia. And so the GDP deflator doesn't include goods that are produced or purchased from other countries. It only includes goods that are produced in that country that we're looking at. Okay. And then the producer price index, it's going to look at the average price not spent by consumers or not paid by consumers, but the average price received by producers. Now, this might seem like it's the same thing, right? If I pay $10 for a good, that company receives $10. Now, the reason why it's a little bit different is because when we're looking at goods that are purchased and sold, typically they're the final product, right? But in order to make that product, there might have been a lot of purchases that were made along the way to buy all the raw materials to produce that. So, for example, semiconductors, it's a very popular data set, something used in economics because semiconductors are used to produce most electronic products. So if we don't include semiconductors because the average consumer is not buying a semiconductor just on its own, But we know that to produce laptops, phones, that semiconductors are used in the production process and that those producers are purchasing them along the way, we want to make sure those are included. Those intermediate goods are also included in our price index, okay? Because those costs of the companies essentially get passed on to consumers. So just different measures of price indexes. Once again, we would still calculate inflation the same way. We would just be using a different price index. So, we could look at, if I look at that producer price index and the consumer price index, they're pretty similar. They're a little bit different. You can kind of see there's larger differences in certain time periods, but they follow the same trends, right? When both these price indexes are increasing, they're both increasing. When they decrease, they're both decreasing. Now there's a discrepancy between them, right? That maybe when times are good, that producer price index tends to be a little bit higher. When times are bad, that producer price index tends to be a little bit lower, but they generally follow the same kind of cyclical movement, okay? So we can also think about when we're measuring inflation that it's going to vary, right? If I look at global inflation rates, it might vary by country. So here I've got just 4 countries that were selected. You notice here, I think it's Japan actually had some deflation in a lot of these time periods, but most of these trends across all countries are similar, right? So if you go back in the 70s, inflation rates were very, very high. They're a lot lower now, okay? So we've talked about how we calculate these inflation rates. How do they influence consumer decisions, producer decisions? We'll now talk about that, okay? So if we're thinking about the differences between nominal and real value, okay? Nominal value, and we kind of talked about this a little bit in terms of purchasing power, we just didn't give it these terms. Nominal value or income is just whatever income I make. So maybe I'm making $50,000. So whatever the current price of a good is in current dollars or the current value of my income and what the current dollars are. Real value, right, adjusts for the fact that even though I'm making $50,000, it's not, the current dollar price. I want to compare that to other time periods. I need to adjust that, right? If I have the same $50,000, but prices are higher, we said last class, I can't purchase as many goods. So real value calculations are giving me that purchasing power. Now we said last class, even if nominal income goes up, real income could go down if prices increase by a larger factor, right? We worked through a lot of examples of that last class, okay? So we're now going to think about, so real values or real income, you can think about how many goods or services could we buy with $1. We talked about this last class. The easiest way to think about this is income over prices or the value of a product over its price, okay? So we went through these examples last class. I went a little bit out of order just based off of where we were at. So we won't kind of rehash these, but really we just weren't giving the term of nominal and real value. We were just calling it purchasing power. Right? Same idea though. So let's now think about how this topic or this concept of nominal and real value is going to be applied to interest rates, okay? So interest rates are going to be how much I have to pay in order to borrow a certain amount of money, or if I invest into something, the payoff that it's going to give me, okay? So we can think of it as the rate an investment earns or the rate at which a borrower has to pay. So real interest rates account for the fact that even if I'm investing in the current interest rate is 10%, I'm making that amount of return on my investment. Well, the money that I'm making has less value tomorrow. So if the investment doesn't occur until tomorrow and I've got inflation, well, then that investment is worth less, right, than what I expected, right? Because if I thought it was going to return 10%, that same return might be worth less tomorrow if inflation is 7%. Okay? So it's going to factor in, when we calculate these real interest rates, it incorporates what the rate of inflation is. So when we calculate real interest rates, it's that nominal interest rate we expected minus whatever inflation ends up being, okay? So if I had a real interest rate of 10%, if I had a nominal interest rate of 10%, inflation is 3%, my real interest rate would be 7%. I don't think this is anything too crazy here. So let's set up an example and start to think about how nominal interest rates and inflation are going to impact that decision by a consumer or someone who's thinking about borrowing. So instead of investing, I'm going to put this in the context of borrowers, okay? So what would my real interest rate be in this example? Well, if my nominal interest rate is 5, inflation is 8%, well, the payout or the amount of money that I'm having to spend to take out this loan, right? I'm going to pay an amount that isn't worth as much tomorrow. So my real interest rate here would be negative 3%. So what that would mean is if I take out a loan, I'm going to have to pay, so of a $10,000 loan, I'd be paying what, $500? However, that $500 has less value because prices have increased, right? The real value of that money I'm having to spend to take out this loan is going to be lower because of inflation. So if the nominal interest rate, right, is less than inflation, should I be borrowing? Well, in the kind of toy example here, if I borrow 10,000, the amount that I've actually paid is whatever that real interest rate is. Well, if the real interest rate is negative 3, that actually means the amount I'm paying is negative 300, which essentially means I'm getting paid to take out this loan. So if nominal interest rates are ever less than inflation, well, instead of when I borrowed that 10,000, the real value of that loan that I was borrowing, taking out $10,000, oh, sorry, there we go, is actually 10,300, right? Because I paid negative 300, that would get kind of added into the original amount. So the real value of that loan to me is 10,300. Now, if I don't take out this loan, right, what would the value of that $10,000 be if I wasn't having to pay back that nominal interest rate? Well, that $10,000, right, would now, inflation makes it worth less. How much less? 10,000, I have a typo here. Sorry, not, right, so 10,000, right, its value is going down by 800. So the value of that $10,000 is only 9,200. I'm actually much worse off if I didn't borrow than if I did, right? That value of 9,200 is less than 10,300. So anytime the interest rate, the nominal interest rate is below inflation, it makes sense to borrow. Now, if it makes sense to borrow, it would mean that what makes less sense to lend that money or to invest that money. Because maybe it's easier to think about investment. Yes, I'm making 5% on whatever my investment is, but it's essentially like depreciating, right? It's worth 8% less in the following year if that's inflation. So we'll work through some examples that answer the next two questions, which is what if nominal interest rates are greater than inflation? And what happens if we have deflation? Okay. So here we'll work through some examples. So let's say I had this situation where my nominal interest rates were greater than inflation. The answer is going to be, it depends, right? So we can think about a first scenario. So if my nominal interest rate was 8% and inflation was 6%, right? So I can think about what would the real interest rate be? The real interest rate is my nominal interest rate minus inflation. So my real interest rate here is 2%, okay? So that means if I take out a loan, the amount of money it's going to cost me is whatever that loan amount is for, times my real interest rate. So here, it's going to cost me $200, okay? Which means even though I got $10,000 from this loan, I spent $200, the value that I have left would be $9,800 from taking out this loan. Now, if I hadn't taken out the loan, right, or I had that $10,000 and I wasn't having to pay any interest rate, what would I be losing? Whatever inflation is. So here I'd be losing $600, or that value would be $9,400. I was better off if I took out the loan. Okay. Now, a second scenario would be, let's assume we have that same nominal interest rate, but inflation is relatively low. Okay. We would go through the same thought process. My real interest rate in this scenario would be what? 8 minus 2, or 6%. So if I take out this loan, I know that I'm going to be paying what? $600. So the value of that loan was actually what? $9,400. Whereas that same $10,000, if instead of paying the interest rate, I just had inflation that was reducing its value, it would be reducing the value by 200. So I would have what? Oh, sorry, this is not, I skipped a step here, right? 10,000 minus 600 gives me 9,400. And then 10,000 minus 200 gives me 9,800. So I now can see if I take out the loan, that real value is less than if I didn't, right? So it depends on if inflation is relatively high compared to the current nominal interest rate, it still makes sense to take out that loan, to borrow that money. However, if inflation is relatively low compared to that nominal interest rate, it doesn't make sense to borrow. Now, what's the, I said it depends here. Outside of this class, kind of the next level, intermediate macro, you could actually, determine what is that relative size of the nominal interest rate to inflation, where that decision would change. Here, we just want to think about it could change depending on if inflation is relatively high or relatively low, right? I kept the nominal interest rate the same here. Okay. Make sure, okay, I got a question, sorry. Are they both meant to have income in parentheses? Is that something they have in common? What were you, sorry, I missed, it was, once again, if you ever ask a question in the chat and I miss it, feel free to unmute. What were you referring to? That was a question on the previous slide. So let's see. So we're talking about this one here. Oh, you can't see this, can you? Sorry. This slide. If you want to unmute, maybe that'll make it easier. Type in the chat. So were they both meant to have income? Oh, yeah. So I was just saying we can compare nominal or real value of a good. We can compare nominal income to real income. It would be kind of the same idea. So instead of income over prices, if I was thinking about nominal versus real value of a good, it would just be kind of, you can almost think about utility over prices, right? Does that help clarify? Okay. So where did we, oh, I had one more example I wanted to work through, which is what if we had deflation? Okay. So if we had deflation, once again, I know I'm enunciating this weird, but just to kind of make this point. So let's say we have a third scenario where nominal interest rates are still 8%, but my inflation is actually negative 2%. Well, under this scenario, my real interest rate, if it's my nominal interest rate minus inflation, well, if inflation is negative, essentially, I actually end up with a real interest rate that's higher than the nominal interest rate. So if I borrow $10,000, what am I actually paying? Right? I'm actually paying 1,000, which means the value of that loan is what? 9,000? Whereas if I had that same $10,000, if I have deflation, this is negative 0.02. I'm actually not paying 200. I'm making $200, right? All of these were kind of reflecting how much I had to pay for the loan. I'm essentially getting paid here. So if I don't take out the loan when I have deflation, then that value is actually higher. So if we ever have deflation, it always makes sense not to invest in that loan. Right? Any questions on that idea before we keep moving? Now, if this is bad for the borrower, who is this a good thing for? The lender or the investor. Okay. So we'll kind of look at this in a slightly different context. So instead of the borrowers here, when we move on to the next topic, we'll start to think about the investor. Okay. So I think here, before we get to that, I'm going to start daily quiz. All right. So if you're starting it with me, I think I have it set to be 8 minutes. There'll be more than enough time for us to kind of get through these. And it's a little bit of review, some stuff we talked about earlier in today's class, but we'll take a look at this here. Excuse me. So I've got 2 time periods, right? And is this what I wanted? I think I flipped these. So sorry, let's use 2000. And so this should be 2010 and this should be 2024. All right, so I kind of have the years flipped here. So if we're working along with me, this should be 2010, this should be 2024. Okay. So I forgot to change that before class. So I've got these three quantities of these different goods. I have their corresponding prices. So we're going to see, okay, what if I were to calculate what is inflation between these 2 years? So if I want to calculate inflation, I need to take the price index of 1 year minus the price index of the previous year divided by the price index of the previous year. Okay. How do I calculate price indexes? I look at the cost of the market basket. So I've got my market basket quantities, the prices in each year. Well, one way I could do this, right, is to simply use, what do I know the price index is if I use 2010 as my base year? So if this was, sorry, I should have flipped these over. I'll write this out on the document here in a second. If I'm using 2010 as my base year, what is this going to look like? Okay, so bear with me. Flip these around. So we had quantities of these three goods were 16, 3, and 4. 2010, we'll kind of use those prices to be 0.25, 1.5, and 2. And then in 2024, we've got 0.35, 2.25, and 2.5. I'll edit the quiz after class so it kind of switches those years to be correct. So if I wanted to calculate the cost of my market basket in each one of these years, I would take the quantity, multiply it by the price, right? I would do that for each good, right? This is the cost of my market basket in 2010. I could then do the same thing for 2024. I take my quantity, multiply it by the price of that good in my new time period. I've now got the cost of my market basket in both years. Okay. Now, one thing I could do here is I now need to turn these into price indexes. But if I use 2010 as my base year, what will the price index of 2010 be? Has to be 100. Okay. If I want to find the price index of 2024, we said, how do I do that? I would take 100, multiply that by the cost of my market basket in 2024 over the cost of my market basket in 2010. Okay. So I do this calculation here, and I have this written out by hand, but we could do this in Excel as well. So I'm going to go to this quiz. I'm going to highlight these values, just paste them into Excel here. Right. Here we can switch the years. Right, so they're correct. So how would I calculate my price index here? We said we would take quantity times the price of each good. So that's the cost of my market basket. The quiz on this one seems, oh, it has set to 5 minutes. Hold on, let me make sure. Okay. How can I adjust this? Oh. So I'll give you the answers real quick. So this should be 38.13 if I remember correctly. If not, I'll adjust it so it accepts that after the class. So 38.13. And then down here, our answers should be, if I remember right, 7%. And then this should be the real value. I believe it's increase here. So there's deflation, investment. Yeah, should be increases. Okay. Sorry, if you want to get those in and get that submitted. Since there's this issue, if it caused any issues here, I'll just kind of give anyone credit as long as you got a response in there, or I'll open it back up after class. Sorry about that. Next time, if you see that, let me know. I can try to make sure that kind of we go through it pretty quickly. Okay. So I want to make sure here, right? I want to make sure we kind of go through and solve these, right? So preview this again so we can take a look at it. Sorry about that. So I've got my cost of the market basket in 2024. I can do a similar thing, find the cost of my market basket in 2010. Once again, you could do this by hand, right? So if I want to find the price index for 2024, I take that cost of my market basket in 2024, subtract that by the cost of my market basket in 2010, divide that by the cost of my market basket in that base year. Okay. What did I forget to do? Oh yeah, I've got to multiply that by 100. Okay. No, did I have something wrong here? So prices, nope. Okay, we're good. And then I took D5 minus C5. Okay. So I was a little bit off on remembering what the exact number is, and we'll see why here in a second. So if I then wanted to, so here's my kind of price index for both time periods. We said if I use 2010 as my base year, I know the price index has to be 100. What did I do wrong here? Hold on. Cost of my oh, I'm not subtracting this yet. This is to calculate inflation. We were just calculating the price index. So, all right, there we go. So here is my price index, right? 100 multiplied by the relative kind of ratio of those market baskets, okay? So I've got my two price indexes. This is formatted wrong, but here we go. Oh, where we go, data. No, it doesn't matter. There we go. So here's my two price indexes. If I now want to calculate inflation, I would take the change in my price indexes, divide it by the base year, or sorry, my old price index. And then we said to kind of make this more readable, we multiply by 100. There I get 35.45. Okay. So this one, it makes it a little bit easier because I only have two time periods. I can kind of treat time period 1, right, as my base year. And then kind of come up with that inflation rate. So 35.45. So once again, I'll just get on. I'll give anyone credit as long as you submitted this quiz, because I ran out of time and I didn't do this calculation ahead of time. Okay. Now for the second question, here if we're thinking about if I've got nominal interest rates of 5% and predicted inflation is 4%, right? And actual inflation is -2. Well, we haven't talked yet about predicted and actual inflation. So we're just going to use the actual inflation of -2%. So the real interest rate would be 5 minus -2, or 7%. And then if I actually have this deflation of -2%, then the real value of a project 1 year from now, after an investment is made, relative to what it would be with this predicted inflation, is actually going to be higher increase, right? Because if I thought before inflation was going to be 4%, the real value that I would have returned is 1%. Whereas if actual inflation is -2, the real value that my investment would return is 7%. And so that value of that investment is actually going to be higher than what I expected or what I predicted. Okay. Sorry for that. Any questions? I had it changed from my other section. I forgot to go in and kind of update this, update the time and question 1 here, switching those years. Okay. And we'll kind of save this so it's in there as well. Any questions on that before we keep moving? Okay. Okay. So we'll get out of this, go back to our slides. Well, now I kind of already touched on it in that quiz question. We'll talk about expected versus unexpected inflation. So when people make borrowing or investment decisions, they make it based off of the real interest rate. They know inflation is going to occur. They make decisions based off of the real interest rate. Okay. Excuse me. So if I'm thinking about using expected inflation, well, I could be wrong, right? So if I have inflation rates that are below the expected rate, well, that actually means my investment is going to be better off, because if inflation rate is lower, I'm subtracting a smaller number, my real interest rate would be higher. right? So let's think about it this way. If I thought that the real interest rate was going to be 5%, right? When I invested $10,000, I would make 500, and the real value of that investment would be 10,500. Now, if the actual inflation rate is 2% lower than what I predicted, it doesn't matter what the values are. The fact that it's 2% lower means I should have been subtracting inflation that was 2% lower, means the real interest rate would have been 7%, in which case, investing that same $10,000, I expected that payoff to be 500. It's now 700. As an investor, I'm better off. So anytime actual inflation is below predicted inflation, I'm actually better off as an investor. What if inflation is higher than expected? Well, remember, to calculate the real interest rate, I'm subtracting inflation. So if I expected it to be 5%, but in fact it is 10%, that's going to lower my real interest rate, which means as an investor, I'm going to be making less money. Okay. So go through some examples here. So who benefits when we have lower expected inflation? That's going to be investors or individuals who are lending out money. Well, if the investors benefit from lower expected inflation, who's going to be hurt? Borrowers, right? So you think about why. Well, if inflation is lower than I thought before, then the real value of my wages is going to be higher than what I thought it was going to be, right? And then also the amount paid on my loan is also going to be higher than I expected with lower inflation. That real interest rate would be higher than what I expected. So here I'll kind of give you maybe a nice summary of thinking about this. So let's say I had, so let's say my actual inflation rate is greater than my expected, right? So just to kind of give you an idea, let's assume I had my nominal interest rate was 8% again. I thought inflation was going to be 5%. That real interest rate would have then been what? 8 minus 5, or 3%. So as an investor, I thought the return on my investment was going to be 3%. If instead actual inflation was only 2%, well, then my real interest rate would have been 8 minus 2, or 6%, in which case I'm actually going to make more money on investment than I expected. So when the actual interest rate is less than what I expected, I'm making more money on my investment. So here, you think about investors gain, or investors kind of benefit from this, which means borrowers lose or are hurt by this. Okay. Now, if I have the flip side, if I'm investing and I think that nominal interest rate that I currently have is 8%, if I expected 5% inflation, but the actual inflation is higher, so let's say that instead of 5%, it's now 7%. Well, now my real interest rate, instead of that expected value of 3%, now it's going to be what? Only 1%. So you can imagine if I'm making this investment decision, if actual inflation is below my expectation, if I was willing to invest at a rate of 3%, well, then I would have been more than willing to invest for the actual rate of return, which was 6%. On the flip side, if I expected that same 5%, I would have been okay making that return of 3%. However, if actual inflation is higher than what I expected, well, maybe I wouldn't have made that investment if I knew the return was only going to be 1%. Okay? So here, when actual interest rates, or sorry, actual inflation is higher than expected inflation, investors lose, which means borrowers gain, right? If I was expecting to pay 3% on a loan, right, but instead I'm only paying 1%, as someone who's taking out that loan, I benefit from this. So this is kind of like using some numbers to show this. This is like a nice summary, right? When actual inflation is greater than expected, investors lose, borrowers gain. When the actual rate is less than expected, investors gain, borrowers lose. Okay? Questions on that before we keep moving? Okay. So with this idea in mind, right, let's say I have the data below, right? What years are investors or those lending out money going to lose out? Well, we just said if I'm making an investment based off an expected rate, if the real interest rate or the real rate of return is lower, investors are going to lose. Well, when is the real interest rate lower than the expectation if inflation rates are higher than I predicted? So any year in which the actual inflation rate is greater than what I predicted, there investors will lose, right? Sorry, I was talking and not thinking about what I'm saying. Let me be sure I said that correctly. Anytime the predicted inflation rate is less than the actual inflation rate, then the investors are going to lose. So I looked through here, 2002, the predicted inflation rate was actually less than the actual inflation rate, so investors lose, and that was the same in 2004. So 2002 and 2004, investors will lose. Anytime the actual inflation rate is less than the predicted rate, investors would gain. So 2001 and 2003. Who gained or lost in 2000? Nobody, right? Because everyone was making decisions based off of a predicted rate of 3%, and the actual rate ended up being 3%. So let's use one of these years once again, just to I kind of already went through some examples, but let's do it again, right? So why in the year 2004 did investors lose out? Okay. Well, if I set the nominal interest rate at 10%, then the rate of return I was expecting must have been what? The real rate of return would have been 10, the nominal interest rate minus inflation, or expected inflation of 4%. So my expected or real interest rate I thought was going to be 6%. However, once maybe I looked at this and I said, oh, okay, I'll invest, right? I'm getting some amount of money off of this, right? I'm getting paid 6%. If the actual return using the actual inflation rate was only 3%, well, I'm still making money off this investment, right? So I still should have invested. However, there is going to be a cutoff point. As soon as the actual inflation rate goes above 10%, I'm actually going to be losing money. So when I'm making decisions based off the predicted rate, I might choose to invest sometimes when in fact I shouldn't be. And in this kind of example, I'm just comparing to zero. But in reality, just because I'm making money on investment, in practice, there's also going to be costs. So I won't throw this at you in a problem or ask you questions that are factoring in these costs. Here, I'm just going to maybe ask you a question of, did investors gain or lose? In this example, they thought they were going to get 6%. They only got 3%. Investors lose out. Right? Which, on the flip side, if borrowers thought they were going to pay a 6% on a loan but only paid 3%, they benefited from the fact the actual inflation was greater than predicted. But if I'm thinking about if there are costs to that investment, then I made the decision maybe to invest when the return was 6%, given my costs. But if the actual return was only 3%, if that's less than the cost to make this investment, I shouldn't have been investing. So if we're using expected or predicted inflation rate relative to the actual rate, it could make our investment decision actually incorrect, could make us worse off. Once again, if the actual inflation rate here was above 10%, I'm actually losing money on this investment. Okay. So that's kind of the idea here. Okay. All right. Is there anything else I want to say? Oh, when lenders lose, that means the borrowers gain. I kind of already said this. And then on the flip side, what if predicted inflation was actually greater than the actual inflation? Okay. So I'll kind of work through an example here. So let's say we had a scenario and I'm going to think about, I've got the same kind of setup. I've got nominal interest rates are 8%. My expectation was that they are, oh, we already kind of worked this, so sorry. We can do it again. There's different values. So let's say we do 10%, kind of our similar example, and we expected the interest rate to be 4%. If our actual interest rate ends up being not greater but less, 2%, well, what would my return on investment be, or what was my expected real interest rate? It would have been 10 minus 4, or that's 6%. However, if the actual interest rate, or the actual inflation was lower than what I expected, my actual interest rate would have been what? 10 minus 2 or 8%. So anytime the actual interest rate, right, is greater than my expected interest rate. Oh, wait, did I do my math wrong here? Did we already go through an example? So the actual rate, sorry, we already did that one. We're down here. The actual rate of 2, right, is below the expected rate of 4. So in those cases, the amount of return I'm getting on my investment is actually higher. Investors gain in that scenario. Okay. So just different examples with different numbers here. I think I went through quite a few that kind of hopefully help solidify this idea. Okay. All right. So we'll go to this next slide. So we're thinking about this in terms of borrowing and investing, but we can also think about this interest rate and inflation as not interest rate, sorry. We can also think about how inflation rates are not going to impact investment decisions, but impact workers. Right? So I looked at the labor market a little bit in last class. We'll think about how kind of workers are impacted here. So one thing that you can see written into contracts are called COLA agreements or cost of living adjustments, right? So this would be something like, we know the real value of someone's income is whatever the nominal value I'm being paid. So let's say I make $50,000 last year, I make $50,000 again. Well, what's the real value of that $50,000 in that following year? Well, it's going to be that same nominal value of 50,000, but we're going to have to scale it, right, by whatever the relative kind of price increases or decreases were. Okay. So in order to have the same real value, right, if prices are increasing, right, that means that I'm going to take that nominal value, multiply it by kind of a value greater than 1. I would have, a real value of my income that would have to be higher in order to keep my purchasing power the same. Okay. So in my cost of living adjustment example, right, if I'm being paid $50,000, well, I know that the real value of my income the following year won't be $50,000. So what would I have to pay someone, right? What would that real value I'd have to pay them be in order to keep really or what nominal value so would I have to pay them in order to keep the real value the same? I can't pay them $50,000 because I know if prices are increasing, in order to keep real value the same, I need to pay them a higher amount. Okay. So what would I have to pay them in order to make their purchasing power of that $50,000 remain constant? Okay. So what I would do is kind of say, okay, if I have this rate of inflation, I'm using these price indexes, and I determine that that rate of inflation here is approximately like what? The ratio here would be about 10%. I would have to take that nominal value of 50,000, multiply it by that ratio of my price indexes to determine what income I would actually, what amount of money I would have to pay them, what their income would have to be in order to keep my real value the same. So in this case, I would take 50,000, multiply it by 1.1 over 1. I'd have to pay them $55,000. Okay. So this is how kind of cost of living adjustments in terms of written in the contracts would work for, to make sure workers are being paid the same real value year to year. Okay. Now, maybe, I think hopefully this is a little bit more of a realistic but applicable example to you. Hopefully you're earning more than minimum wage, but we can kind of think through this, right? So let's say we think about the minimum wage and we think about really what is the government trying to do, right? Well, they know that if prices are increasing, then in order to have the same real value, if the nominal value stays the same, then the real value actually is going to be decreasing for that same amount. So I'm going to have to increase this nominal value if prices are increasing to kind of keep that real value constant. So let's think about what this would look like. Oops, there we go. So if I've got my minimum wage, and in 2000, that federal minimum wage was 5.15, okay? And I have my price index in that year was 172. If, the federal government increased the federal minimum wage. Now, once again, I know states have different minimum wages, but here we're just assuming that this person is being paid the federal minimum wage. So if the CPI in that newer time period is 255, what would the real minimum wage be from 2000, right, in the year of 2019? Well, we would take the nominal value of that minimum wage, which was 5.15 from the older time period. We would multiply it by the ratio of those price indexes from the current divided by the previous time period in order to determine what was the real value of that minimum wage currently in the year 2019. So if I had that value of 5.15, if it was correctly adjusted for this increase in prices or using the relative size of those price indexes, then that value of 5.15 was really worth 7.63 in terms of today. Now, what is the current federal minimum wage? It's only 7.25. So in order to keep the real value the same, the government should have increased the minimum wage not to 7.25, but to 7.63. Okay. So this kind of goes to show that, yes, the government is trying to update, nominal wages to keep up with price increases, but it's not perfect, right? If they really wanted to kind of keep that real value the same, they should have increased that 5.15 minimum wage to 7.63. Okay? So the actual value of minimum wage is actually less than what it should be. The value of that $5.15 in 2000 was actually worth more in real terms than what the current federal minimum wage is. Okay? Now, what if prices decrease? Well, at the same time, minimum wages increase. Right? So if the federal government is increasing this nominal wage, right, but prices are decreasing, well, what's going to happen there? It depends, right? Because if prices are decreasing, then the price index in 2019 is going to be, if I can get this to, there we go, decreasing, or I can think about it as my older prices are higher. Right? So if prices decrease, that means like my older prices were higher. While if at the same time I have increases in my nominal wage, what's going to happen to my real wage? Well, increases in the nominal wage would increase the real minimum wage. However, in the older price index or decreases in prices, if this denominator is higher, that would decrease this fraction, pushing the real minimum wage down. The answer is going to be it depends, right? So even if nominal wages are updating, if we ever have price decreases, we can't say what's happening to the real value of our minimum wage. On the flip side, we could also think about if nominal wages were, for example, what if nominal wages were decreasing, but I then had prices actually not decreasing, but increasing, right? Well, there it would depend as well. Now, in practice, if we look over time, usually prices are going up. And when the government kind of increases nominal wage, that should increase our minimum wage, our real wage as well, right? So if these are working in the same direction, we expect that kind of real minimum wage to go up. Okay. If the adjustment is being made correctly, right? This is kind of our COLA adjustment, right? If this isn't made, then if nominal wages remain constant, price increase would always decrease that real minimum wage. But this is kind of what that minimum wage would have to be in order to kind of have this cost of living adjustment keep the real value the same. Okay. So if we look at graph over time, something that's I think it's kind of interesting here. We've got that minimum wage, and like the government adjusts it every so many years, so we can see that the nominal minimum wage is increasing over time. However, we know that prices are also increasing, right? So are they adjusting the minimum wage so that they're actually keeping real minimum wages the same? Well, here, this blue line, we're looking at if this was adjusted for inflation, if this was the correct cost of living adjustment, here is my real value of my federal minimum wage. It's actually falling, right, in most time periods. So even though the nominal wage is increasing, the government isn't adjusting that federal minimum wage enough, right, to account for the fact that prices are also higher. So even though real minimum wage is going up, it purchases fewer goods than before because prices are also increasing. Now you can kind of notice when they have initially these nominal increases, initially that causes the real value to go up. However, then over time, as prices increase, the real value decreases. And then they increase the nominal wage again, spikes, but then prices increase, the real value decreases, similar kind of thing here. Whenever we have this constant minimum wage, I mean, there are times when we could have deflation, but for the most part, if we look over all time periods, we have inflation. So when we have that nominal minimum wage increase, as years progress, inflation causes the real value to go down. And then when we get over here, we can kind of see nominal minimum wages in these current time periods, right, are actually a little bit higher right in 2020 than they are of the real value. So I think the numbers I used earlier were 2019, and the real value, if we had these cost of living adjustments, was just slightly above that $7.25 because we've had more inflation. The actual nominal wage here is actually made just a little bit higher. I mean, we can barely see it here, right, in 2020, but it's the real value is just a little bit below what that nominal value is. Or when I say the real value, if we had made that cost of living adjustment. Excuse me. Okay. And here, cost of living adjustment, think about this is like the inflation adjusted minimum wage. Okay. So we've got a few minutes left. Let me think if there's anything I want to say. So I'll get those quiz results added, so no one will lose points there if you didn't get it submitted in time. I'll kind of adjust the due time to make sure that everyone's kind of given credit for that. Also, I know there was that issue where the years are mixed up, so I'll kind of get that replaced on Canvas so that when you're reviewing that daily quiz, it'll have that year updated, and that should cover it for today. Let me think if there's anything else I want to say. So I mentioned before tomorrow, make sure you get that module 3 reading done. The quiz that covers module 1 and 2 is now posted. Opened at 3:30. It's posted on Canvas, and it'll be due at the end of the day on Friday. You've got those practice problems that are going to help you with that. So let's see if I have any questions here. So it disappeared from top hat. So I thought I updated this. Let's make sure. If I didn't, I thought I have it set, so it should be review for everyone now. Double check on this since I'm getting a question. So it looks like it's set for review. So started as review. I had to reset it, so there should be no end date. It should be visible. If it's not, send me an email, and I can check on your individual account. But it looks like it's set, so you should be able to see it now. Let me know if this isn't the case. Okay. If not, I'll have to figure out why that's not showing up. But it looks like here I've got it set so that you should be able to see it as review. It's not an assignment, right? It was worth 0 points. Also notice because that module 2 due date has passed, that one is also now set for review. So you should be able to kind of go on and now review that as well. And then module 3, once its due date passes, it'll be set so that you can go back and review it too. Okay. Any other questions before I'll end the recording here. And if you still have questions,